Hi, welcome to ToddFun.com. Today we're going to talk about, review, and tear down my new Variac. A Variac is an autotransformer. It's used to control or to vary the voltage from AC mains. So AC mains comes in, AC mains comes out, but you vary the voltage on it. Now you refer to it as an autotransformer. Now don't confuse auto with meaning automatic or something like that. It's actually comes from it's sourced from a Greek word meaning self, auto meaning self. And that's because an autotransformer actually just has one winding, unlike a transformer which has usually a secondary and a primary separated windings. An autotransformer only has one winding, and you're simply controlling the dial where that second winding point is off the pickup. And we'll see that when we tear it down, how that looks inside. So it's an autotransformer in that sense. Now Variac is the word that I use and most everyone else uses because early on it was invented or coined and trademarked by General Radio. They had it for decades and decades and coined Variac for essentially a autotransformer, varying transformer. And then in 2000, I think the wiki research I did said 2004. I think it's instrument service. I believe it's instrument service, electronics or electronic instrument service. They purchased the trademark of Variac. So really, you can't really. It's not. You wouldn't look it up as a Variac, but you will find it that way. Its non-trademark name is Autotransformer. Now, I've wanted one for a long time because I've used some in labs and stuff in my time. And they're very handy when you're dealing with AC mains and you want to step down that AC mains to a lower voltage and you want to do it nice and smooth. And that's what the dial is for, a nice smooth transition. And I use it for testing equipment. So in this video we're just looking at the transformer, but in my next video, which I'll shoot right after this one, I'm finally going to get to the review of my Monroe calculator, engineering calculator, the 1651. And I've been kind of wanting this transformer to power it up. On my next video, I'm going to open it up, clean it up, blow it out, and then we'll use the transformer, or we'll use the Variac to slowly turn up the power. And I'll be monitoring the current and power consumption with my little kilowatt meter on the front of it, just as a way to know that nothing's frying in my calculator that I'm sure hasn't been on in 20 years or more. And judging by the cord that I'm not so easy to replace, because at the end I might actually test this cord first and just use it for the testing purposes of it, just to let it have one more chance at using this hideous cord. Look at it. Oh, that's terrible. But at least it'll be something I can test and be protected with the Variac. Now, other people use the Variac for controlling AC speed motors, how fast the motor can turn, the temperature on some resistive load, like an old soldering iron that doesn't have any adjustment. People who roast coffee beans and stuff use it to finally control their process. Any place where you want to control your AC mains at a different voltage level, not necessarily always down. Mine goes from 0 to 130 volts, so mine is just essentially just controls it down. Whereas you can get a different type of Variac where, like say you're at a 220 volts as your mains, and you can turn it down to 110, or if you're at 110, you can turn it up to 220. That's a different style than what I got, because I'm not trying to do step up and step down. I'm just trying to do step down from 120 down. And technically it does step up a little bit. It does overwind up to 130. So those are the uses for it. Other times when I need, like say 24 volts transformer, I don't have to go digging up a 24 volt transformer in order to test something like a sprinkler control or an old Commodore or something. I can just whip out the Variac and set my values I want. Other times you might be working with a project and you have to make your own custom power supply, and well, you can do it with straight up with the math and figure everything out yourself with the power supplies and stuff. But rather than fixing on a particular, digging through a box of scrap transformers, wall warts and stuff, you technically can build up and design your power supply without having the transformer, and then use this as the transformer source and work on exactly what level you want everything to run at. And then you can build from there. And then when you know that you have everything working and right, you can order an exact transformer that has the exact voltages that you want for that particular load and currents and so forth. So I'm sure you guys can even post in the notes the things that you might use an Autotransformer for, and that will help anyone else reading the show notes. But let's get to the review and teardown. So there's pretty much how I'm going to be using my Variac. Interestingly enough, it even says Variac transformer, made in China. I wonder if they're paying for that trademark name or not. It has a 20 amp glass fuse. You just unspin this and you get the 20 amp glass, old style glass fuse. A power switch for on and off. Like I say, I like to keep my kilowatt right on the front, on the top one here. Many thanks to Circuit Specialists, where I got this. I buy a lot of my equipment at Circuit Specialists, and they have approached me and said I can, if I need equipment, I can go to them. And they're here in Mesa where I live, so I just drive by them on the way to work anyway. And they said if I need a bit of gear, I stop by and they'll help me out getting it. I do a review on it, which I'm more than glad to do when I need something like this. So that helps me out, it helps them out. So yeah, please support the sponsor. You can order from Circuit Specialists and they'll ship right to you, and they're really reasonable. They got everything from inexpensive product to the top end flukes and stuff. So yeah, big thanks to that. And now I finally have my transformer. This one's about a $99 one. It's 20 amps, so it meets my needs. Bigger could be better, but then I just wouldn't have room for it on in my lab. They do sell smaller ones and bigger ones at Circuit Specialists. I'll put a link to where I got this in the show notes, so you got a quick link. And at toddfun.com. I like the red because hey, this is AC mains, dangerous, And the dial's nice and big and easy to read. The first thing I noticed, though, for a review, is there's little set screws on there. And what I did is I backed off the set screws, and this is the marker for where it's at. And it was overturning the marking position. So I basically slammed it all the way over to where the brushes are all the way to the zero, and then I floated this over to exactly zero and tightened up my set screw. And then once I tighten up the set screw, then this thing stops at zero and doesn't go all the way down to this area like it had been doing. Plus, I'm gonna take and color this piece right here so that I have a nice indicator. I wish this had a better clear, or just this little dimple here it's not enough to really tell. So that's something I'll just alter. I wish they had the sense to make that right from the beginning. Nice steel case. It's a big heavy brute, of course. You have the grounded inputs, 2 plugs on this one, 110 in, and it's 2000 VA. This is not the greatest thing. I don't know if you can see, but if it actually moves when you go to plug something in. So even though I'm happy with a $99 price tag on this, I'm not so keen on this moving, and it was a bit hard to plug a couple things in right at first. It was pretty stiff. It's gotten a lot better now that I've plugged a few things in. So that's that review. Let's take it apart, look inside. Well, a little tape and some yellow paint, and I got a nice marker now. That looks much better. And for taking it apart, you just take off the set screws, but this is what I mean by it goes past zero. So you just want to put it to zero and tighten it down, or actually slam it all the way over and then bring it back because this is floppy, and then tighten it down right at zero, so that your set screws in here hold that at zero for you. So that's going to come off, and I think we're going to have to take off a screw, and maybe this front will come off, and then there's 6 screws around the bottom, and this cage will come off. Make sure you're not plugged in though when you do this, obviously. Yeah, I got those 2 screws off, and this cover just comes off, and then those other 6 screws come, and we'll take a look at it. And this, I think, just slides up right now. Yeah, there we go. There's the cage. There, let's talk about the innards of this. This is the single coil. This, being an Autotransformer, is not an isolation transformer. You don't have the protection of 2 separated coils, you know, that you would have in a regular transformer that has a primary and a secondary. This primary and secondary is the same coil. So no, you cannot use this as an isolation transformer. If you want to have that, then plug this into your isolation transformer, and that will give you isolation. Make sure it's a tech isolation transformer. If you're unfamiliar, see my video on isolation transformers so you know what you got and or need to have. So this is just going to vary your voltage as you turn this. This is nicely constructed, a nice piece of metal here. It's not chinky, even though it's made in China. It's not built bad at all. It's got a couple of big brass floating contacts here. This is a carbon brush that floats right there, and it's a nice thin one. It looks fairly nice. It's going to make a nice even contact with pretty much one coil or 1.5 coils at a time. Good solid springs to hold those brass holders for the brushes down. It's a nice big knob in the center here that is isolated, so this is at no time is this hot or have any current to this, so you don't have to worry about this. And what you have here is the windings. What they do is they expose the top of the windings here, and the brush that I just showed you, that brush there will make contact with the top of the windings, and the top of the windings are ground, so you would have the varnish ground off, and they actually put sort of just a hard resin in the top here, and then they grind it all down, taking a little bit of the winding surfaces off, so your brushes have a nice smooth place to make contact at a particular point of your coil. What you want to look for is that these are nicely even in ground. The grinding is even and smooth, and all these different connections are about the same size. And if you're buying a used one, open it up and make sure that none of this varnish is burnt or somehow have been damaged by overcurrent or something like that. Make sure your brushes are in good order, and that it's making it's not jumping or bumping or scraping or anything. You also can clean this surface here with some contact cleaner. Just when you open it up, make sure it's unplugged. Take some contact cleaner and spray it on a cloth, and then clean this whole surface, and that gets the carbon buildup off and smooths it out. Make sure there's no missing pieces or chunks in this anywhere. Let's talk about how it actually gives you your voltage. Then, looking at the wires here, we'll keep it simple. Coming in on the blue is your what you would call common for your mains household electrical. It's also common for your output here, this larger slot. I look at it like this: the larger slot is always common because the smaller slot is your hot leg, because it's harder to get something into the hot leg than into the common leg. So that's kind of how you always can remember that. And so the common side is shared with this blue line, which comes into this first winding right here. It taps in right here. The brown one is your household mains coming in, and it does come through this fuse first, so that does limit the overall current from your household mains to 20 amps for this device. And it comes in right here, and it comes up to this winding right here. Well, that's a pesky fly. And so from this blue point to this brown point is your normal household current. Common to your household, whatever your household, 120, 115, whatever you happen to have. And what goes on the red line is what goes out to your hot leg, going out to your device that's plugged into this. And that's determined where this brush is at. So if this brush is right here where this 120 comes in, then between blue and this brush, essentially going through these brush leaves, this copper wire going into this collar, and then down this collar and out to this point, so that this point right here is connected to your brush tip. So if that's right here between these 2 points, then you're getting whatever your household happens to be. Let's say 115 sometimes depends on how much load you have on your line and your household connection point. Now if you turn this back, then you're basically changing how many coils you have between the contact point between this common of your output and your hot leg of your output. And you can bring that all the way around until it's the same point, which is 0. So you basically you get 0 volts across there. Now, this one does have overwindings from this point forward, so as you bring your brushes forward from this point, then you get more and more voltage, and this will go up to, well, it marks it at 130 volts, but really it's a certain percentage of whatever you happen to have coming in at the time for your mains to however many windings you have here. So you'll basically have a certain percentage depending on your input from your mains. That's how that works. That's how you take care of it, and that's how you evaluate it. If you zoom in a little bit on one of these, you can see I do not have the cleanest. They're decent, but there's a few spots here where they get kind of thin, and then some get kind of fat. But it'll give you a pretty linear. It'll give you more than a quality linear result. When looking at it, I noticed that there's still some varnish on this one here, so I'll probably have to clean that one up a little bit just to make sure that I don't lose contact with that little bit of paint that's there. Still, it's actually paint, I think, not varnish. But everything else looks really good, really clean. I have a nice stop right there and a nice stop right there with no problems in between. Let's take a look at the electrical wiring inside. Okay, so coming in, we have the green is just your safety ground, and it hooks up to the ground for your outlet socket. We'll talk about that in a second. Is there something about that I'd like to say? It's constructed nicely in that they've put some extra glue in here to hold this mains plug in. You have the black coming up to your on-off switch, which then provides power to the brown, which goes down into the fuse, and then out the fuse into that one hot leg on the coils. And then on the other side you have your neutral for going, your common or your neutral going out. Your socket here also shared with the neutral of the house. And those are well constructed. They've soldered all these. It would have been nicer if they, well, I mean, solder is a great deal because they're in there, they're nice and tight, they're soldered very well, it's not sloppy at all. And but if they had done if they'd used the spade connectors and stuff, then I could easily have unpopped these. If I thought I had a problem, I could have taken parts of this apart and then tested different components like the switch and this, and it'd be easier to do some testing and stuff like that. Then just tapped off either side of the common and the hot leg of your output is a voltmeter. I was saying earlier that I didn't like the way this moves, but really it's bolted in pretty good. I took this screw out, and it's a really deep screw that goes into this, so it's not going to come out. It might wiggle some, but it's not going to be a problem at all, really. What I did notice, and this is back to the ground issue, is that this safety ground for your 3-prong outlet does go to your outlet. Great, fine, wow, but it makes very poor connection to your chassis. Well, that's the job of this, is not just to make sure what you plug in here is grounded, but you want this device grounded. If one of these leaf springs somehow gets snagged and pops up and makes contact with your chassis, well, your chassis could be hot, okay? And you want that to short out and trip a breaker. You don't want to come up and grab this with your fingers and you become the ground for this chassis. That would be terrible. And so this wire, if we can zoom in a little more, you can see they soldered it to something that actually connects here, but it doesn't connect to the chassis. Now, what they're relying on is a little iffy. What they're relying on is that this center screw actually goes in and makes some contact with the metal inside of here for the safety ground for here. So fine, that's great and all, but then there was paint all underneath here, so this screw was not making good contact through the paint, okay, to this chassis. Ultimately, a better solution would be to have just a fat ground basically connecting right off of here to the chassis, and another fat ground coming from this chassis to this chassis, rather than relying on your mechanical fasteners to provide those grounds. But if you prep them by cleaning the threads with and getting all of the anodizing off so you have good electrical contact here and here, and you get good electrical contact here, and you make sure you got good electrical contact here, only then do you have a safe enough system to say, yeah, I'm okay with a fault, this thing's going to ground out properly. That all, of course, relies that you don't defeat your third prong safety ground. Don't ever defeat this, because if you do, well, then all that attention to detail doesn't do any good, because you don't have that system grounding out for you in order to trip your breaker. And let's see, to make this ground, I did grind the paint on there. I cleaned up the threads real good and ground it off there. That will give me the perfect ground that I need, because that's going to be that mechanical fastener is the ground for the chassis. And I've done the same cleanup here, like I said, and I put a lock washer there too, just for extra strength. I've cleaned up these contacts where there was a little bit of paint and stuff on them, and you can clean them with a little bit of really fine sandpaper. If you have any buildup on it, you can buff it off with sandpaper and then contact cleaner when it's not plugged in, of course. Well, I'm going to put it back together now, and then we'll test some voltages. And so, like I was saying earlier about the shielding of shrink wrapping, like this isn't shrink wrapped either in here. It's funny, they did the other ones, but they didn't do the output. So that's really odd. But it's not going to come in contact with anything. I just would rather have seen more shielding. I'm not worried, because once it's bolted together, that will be a fairly decent distance away from the chassis. Okay, so the on switch is on, and it's got a little light. Oh, I'm such an idiot. Okay, so now we turn it up. And we should see the voltage go up. Yeah, okay, so it's reading 50, the dial is reading about 43, so they don't agree, that's for sure. See, we're getting up to, that's 100 on the dial up here. So it's about 10 volts off. And then there's mains and past mains. So, okay, that's not calibrated very well. Let's take a look at it with the kilowatt. That's interesting. Our kilowatt meter won't even come on. I didn't think of that. See there? See, I learned something. The kilowatt meter isn't going to come on until a certain voltage, of course. So you're not going to read. Let's see when the kilovolt kicks out. Kilovolt kicks out at about 20 volts, 25 volts. And yeah, okay. And it's reading 45 volts, 43 volts. And this dial up here is reading 30. The kilowatt is very slow. Let's see, let's set this at 100. That says 100 and it's 100, so really the kilowatt is actually agreeing with that little meter that's behind here, because this is 100 and this reads 110. So it looks like I'm going to have to change the position of my set on my dial. And the maximum it gets up to is 144, which should only be 130. Let's validate all that with the fluke. But at any rate, we'll also test wattage and current with this when we hook up a device. But apparently it's got a minimum on, which of course makes perfect sense. Okay, this is a scary way to do this. I mean, a lot of people don't like putting probes directly in power outlets, but I do it all the time. It's kind of what those are meant for. Just be careful not to touch those probe tips, because they are actually connected to dangerous voltages now. We'll use the Fluke 117 because it has a low Z. We won't get any ghost voltages or anything while we're reading this voltage. It's also auto voltage. Right now it's reading DC, but it's auto. And it's going to be very accurate. So as we turn it up, we'll turn up to 5 on this dial. And we're right at 5, and that's reading 7. So that's this is agreeing with this needle position a little better. Let's go to, say, 20. There's 20, and so 25. Let's see. So that's off by about 5 volts. Let's go 50. That's 50. That's off by 7. Let's go 100. That's off by 110, 100, yeah, 111, 110. So yeah, we definitely aren't going to be very linear with this scale at all. And this would say 130, and we get 144. So the kilowatt was very accurate. It was reading right at about the same numbers within the volt. Well, that's a shame on the knob and or this label. There's no way to make them agree, simply because this autotransformer is not linear in its windings apparently. In that at the lower voltages, like if I bring it up to 10 volts, it says 10 volts here, it pretty much says 10 volts here, it says 10 volts here. But as you climb around, you constantly skew this dial. Even when I adjust it, try and calibrate it off to the slack you're on the high side so that it kind of pushes high quicker. It does not, because it's not linear, it's accurate now down up to like 25 volts, and then it starts losing it. Then by the time you get to 100 volts on this dial, you're basically reading 110 volts here, and you're reading 110 volts here. So this is accurate, but this will never be accurate because it's just not going to do it. So there's almost no reason to even hardly have this. I guess I could reprint my own. I could take and literally reprint this by actually just labeling the. I'll probably just have to create labels at intervals so that I lose this non-linear scale in here, and I have my own outer scale on the top, which will be dead on for what it reads. And that way I don't have to hook up a meter or a kilowatt, and I can even put my own little graduation lines on here. It's a bugger that I have to do that. And I was really thinking this was going to work. I thought this was going to work at lower voltages like 5 volts, but it doesn't turn on until like 40 volts. So it's not going to help me for turning power on, but it will help me monitor power. So let's do that. Let's hook something up and just use it to power something. So let's give this a try. I've got a wood burning iron here. It'll get pretty hot. We'll go ahead and turn it on, and the kilowatt doesn't come on right away, but I'm going to turn it up to about maybe 20 volts. We'll go to just where the kilowatt won't quite turn on. So even though the kilowatt is off, this is going to start getting warm. Yeah, it's definitely warming up. It's definitely getting warm to the touch now. But at any rate, we can just go ahead and bring the kilowatt back up a little bit. We'll give it a little more power, so the kilowatt will come in at about 45, 43. And we know this is going to be pretty accurate because we've already verified it. Power factor is 1 because this is just a resistive load. 60 hertz is going into it, of course. That's not going to change. 3.7 volt amps, 3.9 watt, 3.5 watts. There's our amps right now. So we're getting like 80 milliamps. So we'll just start turning this up, and we'll start seeing it climb, I suppose. 140 milliamps. We'll go to volts real quick and see what the volts are reading. So there's 110 volts. Let's take it up to 120. Which would be, whoops, I over voltage a little bit there. Bring the dial back. It's got a pretty good sensitive control on it. And we'll go. So we're running about 210 milliamps or 0.2 amps to drive this. And this is going to get pretty warm now. I don't want to touch it anymore. But yeah, so with this I can, by plugging in my kilowatt device and hooking it up to the device, I can see, I can dial in what I want. So I can go to my voltage and I can say I want to run this at, say, this is pretty slow responding, but let's say I want to run it close to 50 for some reason. I want it cooler. I can dial in exactly 50. It does pretty decent at that. It's got a pretty fine control, and then once I get there I can see what my current draw is, and power factor and watts and stuff like that. Cost if I cared. Well, thanks for joining. That's my review of the Autotransformer from Circuit Specialists. Like I say, I put a link in there. I buy a lot of equipment from them. And for $99, this thing was pretty reasonable. I didn't have to spend $250, $300 for an Autotransformer that can do my 20 amps. So I wanted something that could do quite a bit of amps because I do motors and stuff once in a while. So that's nice. It's a nice price. I did have some tweakiness. I had to put some nice clear marking on this. I had to make my own graduated calibrated voltage scale on the outside so that I know that when I dial in 45 volts, at 45 volts I don't have to look at this little tiny, it has a meter on it, but it's really small, and I wouldn't want to try and read 45 volts on it. I want to be able to just turn this to say 45 and go, that's 45 plus or minus a couple volts. That's what I want. I don't want it 45, you know, plus or minus 5 volts, you know, plus or minus 1 volt is where I really like to be. And that's kind of where I got this scale at. And that's good. I did have to fuss with the grounds a little bit to make sure these were really good quality connected grounds here, because that is the safety ground for this mechanism. It's there's no extra safety ground straps inside. And I want this to be safe. I don't want to shock myself with this thing. So that said, I wish the kilowatt thing would have worked a little better, but it cuts out at 45 volts. And the other thing with the kilowatt is, yeah, this can do 20 amps, but with the kilowatt hooked up, you can only do 15 amps to a kilowatt. At least that's its rating. So you got to be wary of that. But I will probably use the kilowatt with it a lot, because a lot of times I do want to see what is going on with the current right off, and I don't want to have to put an inline circuit of any kind. And even though the kilowatt's not an accurate amp reader, it really does, but it does a really decent enough job for what I need it for, and it will give me power factor and things like that if I need them. So it's a nice little way of making this a little bit more of a useful tool. But other than that, I like it. Thumbs up. Link in the show notes if you want to get one. Do remember that the next video is going to be using this to power on my engineering calculator. So do come back for the next episode where you get to see this vintage engineering calculator come to life for the first time. And we'll use the Autotransformer for that. That one I've been looking forward to for a long, long time. So, again, thanks for joining.
What?
No, never mind.
It says you're recording, Dad.
Jeez.